Hello from the Forcetronics YouTube channel. In this video, we're going to look at how to build an Arduino shield for the nRF24L01 transceiver, as well as a proto board that'll fit on a solderless breadboard for the nRF24L01 transceiver. In this video, I'm going to assume that you have a basic understanding of the nRF24L01. If not, check out my Getting Started video. I'm also going to assume you have a basic understanding of PCB layout software or the PCB layout software Eagle. If you're new to Eagle, don't worry, there's plenty of tutorials out there for Eagle. Also, I'm going to tell you that you can purchase the shield and the proto board that I'm going to go over in this video at forcetronics.com. So the whole idea here is I'm a true believer in open source hardware, so I'm going to show you how to build this. If you don't want to build it and you want to buy one for low cost, you can go to forcetronics.com to do that. Let's get started. Okay, the nRF24L01, I'm a big fan of it. It's low cost, it's reliable, it's easy to use, I like it. But there's two things about it that make it a little tough to use. First of all, the pin setup and form factor are not great for prototyping. So it doesn't fit on a solderless breadboard the way the pins are laid out. It doesn't easily connect to an Arduino. Here you can see I have one connected to an Arduino Pro Mini. Even if you wire it to the Arduino, it's not a very stable connection because the wires are sort of flopping around. Also, the other downside to it is you often need an energy reservoir to support the transmit power pulses. And this energy reservoir is the electrolytic capacitor that you often see recommended to be used with it right at the power pin. And so this electrolytic capacitor serves as an energy reservoir. So what happens with the nRF24L01 is when it transmits, it pulls a lot of current real quick. And when I say a lot of current, it's actually not a lot of current. It's about 11 milliamps. But it pulls it very fast. And if you have a lot of parasitics between your power supply and the power pin on the nRF24L01, and when I say parasitics like stray inductance and things like that, it prevents the module from pulling that current real quick, and it can often cause the transmit to fail. So you needed a 10 microfarad or around that electrolytic capacitor near the power pin to serve as an energy reservoir so it could quickly ramp up into a transmit pulse. Those are the two main downsides of the nRF24L01 transceiver. And that was the motivation for me to sort of build a shield and a little proto board for them. So here's a picture of the shield that I built. You can see the parts on the left. You can see it assembled on an Arduino Uno on the right. Basically, what I did is I'm using a header here so I can attach the header right here. Here's where the nRF24 is going to go. And since it's on that pin header that matches its own pin header, you can easily take it off, put it on, so it's removable, but it's also in a stable position. Also, if you want, you can solder it right to these if you wanted to. I have the capacitor here right near to the power pin. I have a resistor with an LED to show that there's power applied. I mean, that's actually optional. I allow you to access a lot of the pins, the digital pins. I also use jumpers. So, I route the pins from the nRF24L01 to the appropriate pins on the Arduino to have communication. But I also allow you to remove jumpers to route those pins wherever you want. And you can see here I have a cutout for an SPI or SPI header for the Arduinos like the Duo that do not have the SPI communication at the digital pins. Another cool thing worth mentioning, and I'll demonstrate this, is I actually put I put a proto area, but I also put what I'll call a pseudo solderless breadboard on the shield. So I use these two pin headers, I short all these pins together, and you can put a little transducer or sensor in there, use these power pins to connect to it and the analog pins to read from it or a digital pin to control it, and you can do a little prototyping right on the shield. And I'll show an example of that. And like I mentioned, this is open source. I'll show you where I have the PCB files. If you want, you can also purchase this, though, from forcetronics.com. And the whole idea here was I wanted to make a quality product at a low price. So I think at some of the big maker websites, something like this would sell for probably double. And I'm not putting them down. I mean, I use those sites as well. But my whole point with here was quality product, low price. So you could have this built yourself, but you have to buy the PCB boards. You have to buy 10 at a time. They're going to cost $25 at least. Then you got to buy the parts. If you just want one, you can buy it from me at a fairly low cost. Okay, here's a look at what I call the Proto Board, or the mini Proto Board. So this is actually pretty small, pretty simple. I have the capacitor on there. Once again, I have a header to connect the nRF24 to, and then I just have 8 pins, 4 on each side, to connect to a solderless breadboard. So here's an example with it set up. Here I show an Uno, where, I mean, the shield would probably be a better fit for the Uno, but for other things, or if you have a more complex setup, or if you want to mount it on something, this is a great little board. And this is only going to be, once again, $3, a little less than $3, and you can add the nRF24 transceiver module for $1. Also, I'll sell these modules on forcetronics.com as well for $1.25. Once again, trying to keep the prices low. Now that we just did a quick overview of the shield and the Proto Board, how they look, here's a look at the Eagle files. And once again, I'm not going to go into the design process for these. I'm going to assume you have a basic understanding of Eagle. If you don't, there's plenty of tutorials out there. Eagle is free to hobbyists if you want to download it. So what I'm showing here is this is actually my part that I made for the nRF24L01 connections. All the custom parts that I use in here, a lot of these pins are custom parts, and this and the nRF24 part, they're all custom parts that I made. They're in the Forcetronics library, and on GitHub, where I show you where to access my schematic and board file, I'll also have my library, so you have all the custom parts that I use in here. Okay, you can see the 10 microfarad cap connected right to the power pin. You can also see the optional resistor and LED to show that power is applied. A lot of these pins are just the Arduino pins, or the pins on the shield that connect to the Arduino, as well as some of the prototyping pins. Let's take a look at the board. Here's the board. One thing you notice is the ground plane. I cut it off here because I want to keep it away from the antenna part of the nRF24L01. I don't want that ground plane to block any signals getting to the module. Here's the module. Here's where you would put the header. Here's the capacitor connection, the resistor, the LED. Here's where the jumpers go. Here's some of the access to the digital pins. Here's the solder proto area, and then here's the solderless breadboard area. So notice they're all shorted together, so you can put a sensor in here, and then you could measure it using an analog pin. You can see I route 2 of the analog pins here, and then I have the different power and ground pins available here, as well as the normal Arduino shield connections. Okay, let's take a look at the mini Proto Board. Here's the mini Proto Board. Same part here. Here's my capacitor, and here's the pins. This is just pretty simple. Here is the board layout. Let me do the net list so you can see the ground plane. This hangs way off, so I don't have to worry about the ground plane blocking anything. Once again, this board is fairly simple. These are spaced, these 4 pins, so it'll easily fit on a solderless breadboard. Okay, let's take a look at the boards in action. So in this example, I'm going to show the mini Proto Board as well as the shield in action. The shield is going to be the transmitter, and the mini Proto Board is going to be a receiver. The transmitter is going to send over a reading from a temperature sensor. The receiver on the mini Proto Board is going to take that and display that temperature on the serial monitor. So here's my setup. Here's the mini Proto Board. You can see the capacitor. You can see the Arduino Pro Mini here connected to it. So here I go to the shield to show that. Let it come into focus a bit. Let me stop it there. Here's the shield. Here's all the jumpers. Here's the board itself, of course. You can see the LED. It's pretty bright. And you can see me using the mini breadboard feature. So here I have a temperature sensor, the TMP36, and then I can route power, an analog pin, as well as ground to it. So I can do a little bit of my prototyping here. So you can imagine if you're trying to build like a wireless temperature sensor network, this sort of gives you everything you need to sort of get prototyping quickly and test out your code. Okay, there's the simple setup. And then I'm going to pan over to the PC just to show you the temperature readings as they come into focus. I'll stop it there. So it's just reading the temperature readings from the transmitter. Once again, just showing that these actually do work. In most of my videos, I go over the code. In this video, I'm not going to go over the code. I will post the code on my blog like I usually do. If you're interested, once again, if you're just getting started with the nRF24L01 module and you want a more in-depth tutorial, check out my Getting Started video. Okay, that's it for the video. Here's the link to the Eagle files on GitHub, so you can access the Eagle files, and with the Eagle files is the library component. So, you got to load the schematic and the board files into a new project folder. You got to put the library file in the LBR folder, which will probably be located on your C drive where the Eagle program is stored. For the example code, go to my blog, and once again, I'll be selling these on my website, forcetronics.com. This is going to be 2 of my first products, and then in the future, every month I'm going to add a couple new products. So check it every once in a while because I'm going to have new stuff. I don't have great shipping options for international customers, just because the shipping becomes more expensive than the actual part. Once again, if you're international and you want one of these bad, or 2 of them, I can hook you up. The website that I'm using doesn't offer a lot of options for every single country in the world. So if you're interested in purchasing it and you can't purchase it in the country you're in, feel free to email me. Also, I'll have these on eBay. So just search Forcetronics as well as the name of these boards, and it should come up. Thank you for watching.